Okay, we're still talking about chapter 6, which means we're still talking about logarithm. Well, actually, we're still talking about inverse functions. But in 6.3, actually, we're talking about logarithmic and exponential functions. I was right the first time. So we're now going to talk about section 6.3. And this section has got the somewhat confusing, arbitrary, it's not arbitrary, but somewhat confusing title that says that logarithms are exponents. Now, if you remember back in the first section of this chapter, we talked about exponential functions. And those were things that looked like y equals b to the x. And we've done some work with these, and we've seen that they're difficult to solve unless you know how to get this exponent down out of the exponential spot. That is what logarithms do. So the logarithmic function is the inverse function for exponentials. So this is a new type of function. It's a function just like a square root is a function, or just like squaring a variable is a function. So what we need to remember is when we see y equals log base b of x. I know that looks weird, probably because you might not have seen it before. But this log is the function. The b is the base. And the x is the argument. All right, now let me tell you what that means. If y equals the log base b of x, what that means is that b to the y equals x. Here's what I want you to notice. B, the base, is the base in both the logarithmic and the exponential forms. These two equations say exactly the same thing. It's the same thing as saying y equals the square root of x. That is let's do cube root. That is exactly the same thing as saying y to the third power equals x. Those are two ways of saying exactly the same thing. So is this definition I've got written over here. So the base is the base. Remember this title, Logarithms Are Exponents. The y, which equals the logarithm, that is the exponent. And then the argument on the logarithmic side is the result on the exponential side. Okay, so let me show you some examples here. We know that 8 is equal to 2 to the third power. This also means if we apply our equivalency here, something is going to equal the log base b of something. Now let's fill this in. B is the base. The base is the thing to which the exponent is applied. So in this case, that is 2. Logarithms are exponents. So the exponent is the thing that is equal to the logarithm, in this case 3. And then the 8 goes in the only spot left, which is the argument. So the log base 2 of 8 equals 3 because 2 to the third power equals 8. Let's do another one here. We know that 25 is equal to 5 squared. This, is the exponential form of this statement. Let's write the logarithmic form. The logarithmic form says that the exponent, which is 2, is equal to the log base, whatever our base is over here, which is 5, of the only thing left, which is 25. So the log base 5 of 25 is 2 because 5 squared is equal to 25. So in general, if a quantity equals another quantity to some power, we can go back and forth between exponential form and logarithmic form by using this pattern. Make sure this pattern makes sense to you. It is not magic. There is a logic to it right here, okay? It comes from the definition of the logarithm. With practice, it gets easier, but you do have to be good with exponents. So if you're struggling with your exponential rules, this is going to be hard. Review those exponential rules and try to make sense of them before you do this section. All right, so let's work some, let's put this thing to work. Let's solve this equation. The log base 3 of x equals -2. Now what we're going to do is we're going to write this in exponential form. My base is 3, my exponent is -2, and that equals my argument, which is x. 3 to the -2 is 1/9, so x is 1/9. Now your calculator can only do certain logarithms, so your calculator's not going to be any help here. Probably. Some calculators can do other logarithms. Let's try another one. Let's solve the log base 8 of 4 equals x. Now this is a little trickier, so I'll walk you through it. And we're going to solve this. So we're finding x. That means 8 to the x equals 4. So I still went to exponential form. And here's why. I don't know 8 to the x. I don't know what power would equal 4. But, so here's what we do. We're going to go to the lowest, to the prime factorization of both numbers. So if we think about 8 and its prime factorization, 8 is 2 to the third power, right? And 4 is 2 squared. So this is the same thing as 2 to the third to the x equals 2 squared. Now simplify on the left and you get 2 to the 3x equals 2 squared. Okay, Now, we may not have said it mathematically yet, but it makes sense if we think about it. If we've got a base to some power is equal to a base to another power. All right, if my bases are equal and my numbers are equal, that means my exponents have to be equal. So that means that 3x is going to be equal to 2. So x is going to be equal to 2/3. Let's check that real quick. Let's just take our calculators and plug in 8 to the, in parentheses, 2/3 power. And sure enough, we get 4. Okay? All right. So the best thing I can do for you at this point, I'm going to show you one more example because it is also a little bit tricky. And it is this one. And then I'm going to let you go to just practice this and internalize this definition. Let's solve the equation. Log base x of 4 equals 3. Put it in exponential form. So I want you to notice the first thing I'm doing anytime I'm solving these logarithmic equations is I'm putting them in exponential form. So I'm writing x to the 3rd power equals 4. We know how to isolate that. We're going to take the cube root of both sides. And this is our solution. Okay. The only thing tricky about that is the cube root. And the fact that you don't find a number, you just leave it as cube root 4 because that is the exact answer. All right, so what have we learned in this video? The main thing you need to take away from this is the equivalency between y equals b to the x. That is the exponential form. And the fact that x equals the log base b of y. This is the logarithmic form of the same mathematical fact. We know that 16 equals 4 squared, so we know that 2 will be the log base b of 16. Make sure you can do that translation from logarithmic to exponential form and just work this homework assignment. All right, I will talk to you all again soon.